to the final demo video for Group 12 at University of Central Florida. We are Project Solaris, the solar optimized land autonomous recharge and intelligence system. Please enjoy the video demos that we have provided.
Alright, so I'm going to be demonstrating the stationary mode for Solaris. So currently it is in manual mode. I was just driving the robot around. So I'm going to change it into stationary and we should see the solar arm reorient itself towards the sun. I'm just pointing up there right now. So without further ado, I'm going to press the stationary button on my phone app and we're going to see it start moving towards the sun. Beautiful. Oh, that's it. That's it, yeah. So, as you can see here, we're right in manual mode. I'm going to start giving it some throttle and steering commands. So I'm going to tell it to move forward. So you can see it as I'm driving it. It is moving forward. I can also move it backwards, so directionality works. You can see that here. I can make it go faster, slower, all that stuff. I can give it steering input as well, so I can tell it to turn right, it'll turn right. I'll tell it to turn left, it'll turn left. So I'm going to bring it over to our assistant, Raphael, over here. Alright, so I'm just going to start turning it and bring it over to him. Got it. So here we have the autonomous mode of Solaris. We were originally going to put that pillowcase on the solar panel, but instead we decided to actually disconnect the solar panel from the system entirely. The idea is to generate a power drop. So the way that we're detecting if the solar panel is in shade is essentially if the energy monitor unit that we are using detects a 5% or higher power drop over a course of about 30 seconds. And then after that 30 seconds is finished, it will essentially try to find the direction of the highest sunlight. There's 4 phototransistors on the corner of the robots. And then it will turn into that direction and start driving that way. So pretty shortly here, it's going to recognize that there was a pretty significant power drop, as you can see there. It tries driving towards the sun, and then it will realign itself like that using the IMU. The idea there is the tilt, mainly the pan motor, have limited values, so they can only pan 360 degrees, tilt about 30 to 45 degrees. The reason we do that is so we don't wrap up cords or we don't damage the solar panel or anything like that. So the little reorientation at the end there was to make sure that the solar panel doesn't get damaged essentially, or continuously wrap up, and it still has pretty good degrees of freedom, like movement. So we saw it move again after about another 30 seconds. So it'll make this move decision 3 times before it actually decides to just stay stationary, kind of like in a sunk cost approximation, essentially. We don't want to just continue burning power if it's not going to see higher power draw. But in theory, if we turn the solar panel back on the first time, then it would recognize that the power gain was back to where it was originally, and it would just stop moving. It wouldn't do that 3 times like it has here. And then after 30 seconds after it settles, the solar arm will reorient itself every 30 seconds in the autonomous mode as well, which we will be seeing shortly here. Just give it some time. And there it goes. And that's the autonomous mode for Solaris. Hello everybody, I'm going to be demoing the phone app and Bluetooth functionality of my ESP device. So without further ado, we are at the home screen of the Solaris app. You can either log in or you can sign up. This is a pretty simple thing. I'm mainly just using the login feature to capture the user's token to help us filter through our database for all of our telemetry data. So I'm just going to continue with my Google account. Okay. And we are signed in, and right now we are connecting to the Bluetooth device, and you can see that. And as soon as it's done connecting to the Bluetooth device, it takes us straight to our telemetry homepage. So if we want to take a look at kind of what was happening in the background, I'm going to start here. So this is our logs from the ESP device during the connection. So let's see here. We start with obviously getting the connection from the device, and then the first thing that I do is sync the time. So what I'm doing here is just sending a Unix timestamp, so that way the ESP device knows what time it is, so it can record the device, record the time for the device. Especially important for telemetry data, the way that we're going to go about that, where it's going to be recording telemetry data pretty much every minute, and then we can use that timestamp information to better filter through our backend while we're getting the telemetry data. If we take a look, we also get weather information, so this is going to help us be able to especially detect the cloud coverage percentage, as you can kind of see here. So it gives us a 24-hour forecast. I have to give the phone app, although you didn't see it, I've already done it. I gave it permission for both Bluetooth and location services. So it got our longitude and latitude location from our phone device. And I used that to call my backend service to call just a simple weather API. And that is what returned all this weather forecast information. And I'm just giving it to the ESP device, so especially so it knows what the cloud coverage percentage is, right? So if the cloud coverage percentage is like something like 0% and it's detecting a significant drop in power, then we can safely assume, okay, there is probably a shadow here. When it's 58%, well, then we actually really need to consider some more logic to kind of handle that cloud coverage percentage. So after we do that, the next thing that we do is just send over the telemetry data that is stored in the ESP device's flash. So the way that I went about kind of programming that was doing like a kind of like a TCP type effect, where I break the telemetry data down into like pages. So here we have like 9 pages. It's sending about, I think, around 250 bytes of information per page. So pretty much the phone app is going to start by sending like an initialization, like, hey, I want the first page read, and then the Bluetooth device is going to send that page, and it's going to wait for an ACK from the phone app. Once the ACK is received for the previous page, it's going to send us the next page, right? And it's just going to keep going back and forth on that. If no ACK is received, then it will resend that page's information, pretty much. And we just keep ACKing until we reach the final page. And then once the final page is read, the phone app will send a clear log command, which will pretty much allow the ESP device to just clear all of its flash data of all the telemetry data. So that way, it doesn't have to hold a lot of telemetry data. Anytime that we connect to it, we read from it, and then our phone app sends all that information to the back end. All that telemetry data is then stored on our database, which I will also show. So from the backend's point of view, there's a lot of, so we have like the posts of the telemetry data. So it gets like all the the timestamps, the CPU temperature, battery level, all that for different time frames. And then what it does after it posts, it goes to the telemetry page on the phone app, and then we do this GET request here. And then if we go back to the phone app, we can see just kind of how it's presented to the user, right? So we got all that information from our backend and from our database, and now we're actually, displaying that telemetry data, right? So we can see the current charge. I can also, take a look at past information. Um, so there's like bars, and like these are like averages, for the net power or the past hour. So like buckets it for like past hour, like every 5 minutes, pretty much. And then you can see kind of like the average in that 5 minutes, what it was like at that given time. Same thing with CPU temp. So that's just kind of how we're displaying our telemetry data. We might add more, but right now this is just our basic four that we're displaying. One other feature that we added is this mode. So the Solaris is automatically put into automatic mode, like at startup. But if I want to say put it into stationary mode, so I'm gonna go back to um, the ESP logs, and then once on the phone app I select stationary, you can see that mode change was sent to the ESP. So now it knows, okay, I'm in stationary mode, I shouldn't be moving. I can change it back to automatic. And I can also change it to manual. Now, in manual mode, if we take a look at the phone app, we can see that there's two new joysticks on my screen. The one on the left is locked into the y-axis, and the one on the right is locked into the x-axis. And they both give different information. So the one on the left is how fast we want the Solaris to move, and the one on the right is how fast we want it to steer, right? So pretty simple. And if I, move the throttle data, you can see on the ESP logs the throttle information being sent. So on the phone app side, it's gonna toggle from -1 to 1. On the ESP, we take that data, we multiply whatever it was by 127, since I'm setting the information into a 8-bit integer, and then it gets the information that way. So if I do negative, you can also see it's negative. So it is assigned int, and it will use that data to determine how fast it should be moving, either forward or backward. And the same thing with steering, same type of thing, move left or move right. It's storing that in just an 8-bit integer for both of those. That's about it for the functionality. I will also add that at the telemetry page you can scroll up to just refresh, so it'll call our backend. It'll also give another time sync and more weather information to the ESP device if it's connected. Here nothing really refreshes, so right now I just have mock data being stored on the ESP. So obviously it's not getting more data, but in practice it will be getting telemetry data every minute. So every time that I refresh, as long as the last time I refreshed was something like 30 minutes ago, it should give me like 30 more telemetry data to pull from, right? So we can kind of keep staying in fresh of what the telemetry data is currently looking like, especially like with the current stuff at the front of the telemetry page. So that's pretty much all of the phone app functionality for Solaris, as well as how we're handling the Bluetooth. And all of our telemetry data is just stored on a Supabase database. So yeah, that's about everything.
Project Solaris sincerely hopes that you enjoyed our demo videos, as we thoroughly enjoyed our process and our progress through the entirety of both semesters. Thank you to everybody who supported us, and we hope you enjoyed.